Okay, guys, let's get down to our next new formula here. Before we do that, let's review what the heck is going on with all these other formulas to make sure we're all up to speed right now. Okay, let me just get my magic pen and see what's going on here. Okay, now what we're going to do here today is find the sum of a finite geometric series. But let's recap where we've gone in the past few days. The first thing we learned is the nth term of arithmetic sequence. This is called the generator. A sub n equals the first term plus n minus 1 times d. D was the common difference. Okay? And that's how we find the generator of arithmetic sequences. Remember, arithmetic sequences have a common difference. And then, what if we want to find the sum of those terms in the sequence, the first 5 terms? And that's what we did the other day as well. To find the sum, we use S sub n equals n over 2, first term plus the last term, and that's how we find the sum. Notice these two formulas. These two formulas are usually used with each other. Okay? Now, we're going to continue on here, and we're going to go back to geometric. Right over here, if you take a look at this, A sub n equals A1 times Rn minus 1. That's the generator for the geometric sequence. The nth term, we're going to find the 5th term in the sequence, the 6th term. And remember, R is the common ratio in the sequence. So how do you distinguish between arithmetic and geometric? R common ratio, when you divide the two numbers, any number divided by its previous, get your common R, and any number divided by its previous will get the common ratio. And the arithmetic, the common difference was when you subtract the two numbers, they're in common. So the second to last piece of the puzzle is talk about a geometric series. So we're going to look at a series of geometric sequences right now, and we're going to find the sum of those. So let me slide this up a little bit and get to just a couple problems here today. What's the formula for a geometric series? The series, or the sum of the series of n terms. So you want to find 5 terms, you could do that. The first 7 terms, you could do that. Equals the first term, parentheses, 1, take away r raised to the n, close the parentheses, all over 1 minus r. And we know r is the common ratio. R is the common ratio. So let's try one right now. Okay? So let's take a look at this. Now we're going to lose the formula, but I'm going to rewrite it. So if you want to stop the video to rewrite it, remember it's also on the formula sheet that you guys were supposed to have printed out. Okay, so let's try this problem here. Find the sum of the following geometric series. I'm nice because I told you it's a geometric series already. So therefore, if you know it's a geometric series and you know find the sum, you have to use this formula. But let's make believe we didn't know it was a geometric series. So let's analyze it and see what's going on. Okay, so let's now take a look at this real quick. First, I look at this, the series. Is it geometric or is it arithmetic? Let's make believe we're not told. So first thing I could try is the common difference. 4 take away 2. That is 2. Then we could try 8 take away 4. 8 take away 4. Okay? And when we did that, we get 4. So there is no common difference. So it's definitely not arithmetic. Let's try dividing now. 4 over 2 is 2. Ooh, it seems like it has a common ratio. Let's see. We have to verify its common ratio. 8 over 4 is 2. Common ratio. If you do 16 over 8, 16 over 8 is 2. So now I can go back and look at this. 2 times 2 is 4. 4 times 2 is 8. 8 times 2. Okay, so we know it is a geometric, even though I told you it was a geometric. What do we want to do with the geometric? Well, we want to find the sum of the geometric. So we have to try to memorize the formula if we can. The sum of the geometric is S sub n equals the first term, parentheses, 1 minus r raised to the n all over 1 take away r. Now, what are we really trying to do? We're trying to find the sum of this. And I will agree with you. You might say it'd be faster to use the calculator for this situation because I did make this series small. So you're absolutely correct. You can go like this and check your answer. 2 plus 4 plus 8 plus 16 plus 32. And you can add them all up. And if you add them up, you get 62. If this series was much longer, you will not want to do it this way. You would like to use the formula. But we made it short so we could verify our work. The sum of how many n terms? Remember, this is the first term. This is the second term, third term, fourth term, fifth term. So we'll find the sum of 5 terms. The sum of the first 5 terms in this geometric series. The first term is 2. Then it's 1 take away. What is the common ratio? The common ratio was over here. We discovered r, oops, computer got messed up. R is 2. So the common ratio is 2. We raise it to the n term, 5. We want to be careful when we use the calculator on that. Over 1 minus common ratio 2. So if I compute this, it'll be 2 parentheses, 1 take away, 2 to the 5th, if my memory doesn't fail me, is 32. All over -1. Now, this will be 2 times -31 over -1, and that is positive 62. Worked out very nice. And I agree, if you ever had an SAT question to only answer 5 terms being added together, I would do it this way. But we know the formula works as well. And the formula is very good for a bigger or larger sequence that I'm going to try to give to you in a minute. So we found found the geometric sum of these terms. Let's try another example. Okay, let's try this one here. Find the sum of the first term of the geometric series 3, 6, 12, 24. Okay, let's just verify it's a geometric series first. So let's try it. 6 over 3. That's 2. Unfortunately, I did a common ratio of 2 again. My bad. It's okay. 12 over 6 is 2. 24. No reason to do the next one. We know we have a common ratio of 2. But this one gets a little awkward because we're finding the sum of the first 10 terms. We can figure out the next term. 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48, and keep going. That's a little bit of a work. So we have a shortcut. We're going to find the sum of S sub n. What's n? The number of terms. How many terms? We want 10 terms in the sequence. S sub 10. That is the sum of 10 terms in the geometric sequence. It's geometric. We need to know the first term. Remember, our first term is here. A sub 1 is 3. So it's 3 parentheses, 1 take away, r raised to the nth. What's n to the 10th power? All over 1 take away r. R is what? 2. And I apologize, I didn't put 2 up here. I want to fix that right now. Take my little eraser. And we said r, see this r here? We know it's 2 because I have the common ratio over here. So I fixed that very quickly. And here we go. So 3, first term 3, parentheses 1, take away 2 raised to the 10th equals 1 over -2. So what is this going to be now? 3. 1 takeaway. 2 to the 10th is a pretty big number. That's 1,024. You can verify that in your calculator. Okay. All over -1. Okay. So now if you multiply this, you're going to get 3 times 1,023. That one I'm going to break out the calculator for. So I want to do 3 times -1,023. That is -1,369, -3,069 over -1. So what do we conclude? The sum of the first 10 terms in this geometric series is 3,069. What am I trying to say here? I'm saying if you take the 3 plus the 6 plus the 12 plus 24 and keep going up until the 10th term, you add them, you get 3,069. I have it done down here a little bit lower, and this is what we were saying. Let me bring it up here a little bit better, guys. There you go. And what I'm saying is, if you take the 3 plus the 6, this doesn't fit. That's better a little bit right there. See the 3 here? The 3 plus the 6 plus the 12 plus 24. Okay? Times it by 2, you get 48. Times it by 2, you get 96. Times it by 2, you get 192. Times it by 2, you get 384. Times it by 2, you get 768. Times it by 2. This is the 10th term in the sequence. And if you take the first 10 terms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you add them together, you get 3,069, or use the geometric formula for that. Okay, guys? That's basically it. All right, so go practice and have some fun with it. This is your 4th formula. There's one more formula